In this video, we'll build an intuitive understanding of a quadratic equation. We'll start with the general form, then discuss the x-intercepts, the y-intercept, the vertex, and the axis of symmetry. Finally, we'll solve a full model problem. A quadratic equation in function form looks like this. The equation is y equals ax squared plus bx plus c. This form tells us the shape is a parabola. The x-intercepts are where the graph crosses the x-axis. That means y is 0, so we set the equation to 0 and solve. These are also called the roots or zeros of the quadratic. The y-intercept is where the graph crosses the y-axis. That means x is 0, so the y-intercept is just c. The vertex is the highest or lowest point on the parabola. Its x-coordinate is negative b over 2a. Once you find x, you plug it back in to find the y value. The axis of symmetry is the vertical line that passes through the vertex, and its equation is x equals negative b over 2a. Now, let's do a full example. Consider y equals x squared minus 4x minus 5. We'll find the x-intercepts, y-intercept, vertex, and axis of symmetry. For x-intercepts, set y to 0. We solve x squared minus 4x minus 5 equals 0. This factors into x minus 5 times x plus 1 equals 0, so the x-intercepts are 5 and negative 1. For the y-intercept, set x to 0. That gives y equals negative 5, so the y-intercept is 0, negative 5. Now for the vertex. The x-coordinate is negative b over 2a, which is 4 over 2, or 2. Plugging in x equals 2 gives y equals negative 9. So the vertex is at 2, negative 9, and the axis of symmetry is x equals 2. Let's graph it to visualize all of these features. First, the axes, then the parabola. We'll mark the x-intercepts, the y-intercept, and the vertex, and draw the axis of symmetry. To summarize, we started with the general form, then found the x-intercepts by setting y to 0, the y-intercept by setting x to 0, and the vertex using negative b over 2a. Finally, we graphed the parabola and clearly saw the axis of symmetry. Great work!